Now let us move to the next question, that is 106. Question number 106 says that two radiations of photons energies 1 electron volt and 25 electron volts successfully illuminated to photosensitive material surface of work function 0.5 electron volt. The ratio of maximum speed of the emitted electron is how much? So you need to calculate the maximum speed. For that, you have to use the concept of the chapter dual nature of radiation and matter, which says that kinetic energy is equals to the energy of the photon minus the work function. Now kinetic energy can be written as half m v square, that is v max square, is equals to the photon's energy is given to us, that is how much? Number 1 is 1 electron volt. Let us not write first, minus this one will be h mu naught. Put it equation number 1. You take everyone m for 1 u1 and this is for h mu naught 1. For the next one you will be taking half m v2 square, which will be equals to e2 minus h mu naught 2. But h mu naught 1 will be equal to h mu naught 2 because the work function are same. So this whole term is going to same for both of them. E1 and E2 is given to you. If you take the ratio, now this portion will get cancelled out, right? So just you need to find out V1 by V2. If you calculate V1 by V2, your final answer is coming out to be 1:2. This is the right answer for the question 106. Now let us move to the next question, that is question number 107. 107. For the angle of minimum deviation of the prism to be equal to the refracting angle, the prism must made up of material whose refractive index is. So how you are going to solve this one? You are going to use the formula from the chapter Ray Optics topic prism. Refractive index is equal to sine of del m plus a divided by 2 divided by sine of a by 2. So if you use this formula, then only your answer will come out. And remember, the option or question says that the minimum angle of deviation is equal to the refracting angle of the prism. This is also given to you. So just put this here in place of del m, that is twice a by a, and calculate the value of refractive index. You will see that the refractive index value lies between 2 and root 2. Please use this formula and find the answer. Now let us move to the next question, that is question number 108. If the momentum of an electron is changed by p, then is de Broglie's wavelength associated with it changes by 0.5%. The initial momentum of electron will be. Now the wavelength, the momentum has been changed from p to delta p, and then the wavelength changes is 0.5%. Okay, that is 0.5% of lambda, that is 5 by 100 into lambda, that is lambda by how much? Lambda by, you have to calculate this one. Now my dear students, this question came from the topic de Broglie's hypothesis from the chapter dual nature of radiation and matter. The formula which you are going to use out here is lambda is equals to h by p. In the second case, lambda will change. This is the first case. Second is lambda will be 0.5% of the initial one, and then the momentum will change to delta p. So you have to take the ratio and find the answer. The final answer for this one will be 200p. Please check and get the answer. Now let us move to the next question, that is question number 109. Three masses are placed on the axis 300 gram at origin, okay, 50 gram at 40 centimeter, that is x equals to 40 centimeter, and 400 gram at x equals to 70 centimeter. The distance of the center of mass from the origin is. Now you have to know the formula. This is a question came from the chapter system of rotational bodies, topic center of mass, and class 11. The formula is center of mass is equals to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Fine. All the masses are given to you. X1 will be equals to 0 since it is kept at origin. These two distance will arrive if you see the question. Fine. So this distance can be calculated with the help of this one. The final answer for this question is 40 centimeter. Please note it. Now let us move to the next question, that is question number 110. A car of mass m is moving on a circular level track of radius r. If mu s represents the static friction between the road and the tires of the car, the maximum speed of the car in circular motion is given by how much? This is a question came from the topic uniform circular motion from the motion chapter. Please note it, there is a direct derivation for this question which is done in your videos. See to it and see that the final answer for this question will be given by option number 1, mu s g r. This is the right answer. Now let us move to the next question, that is question number 111. A slab of stone of area 0.36 meter square and thickness 0.1 meter is exposed on a lower surface to steam at 100 degrees Celsius. A block of ice at 0 degree rests on the upper surface of the slab. In 1 hour, 4.8 kg of ice is melted. The thermal conductivity of the slab is given by. So you need to calculate the thermal conductivity. This is a question came from the chapter thermal properties of matter, where the thermal conductivity is given to you, that it is directly proportional to the change in temperature. It is also directly proportional to the area of the conductor and inversely proportional to the distance. If you solve this one and see that, the correct answer for this question will be answer number 2, that is 1.24 joule per meter per second per degree Celsius. So 1.24 is the correct answer. Please see to it. It's a topic. Direct formula is there in the videos. Fine. Now let us move to the next question, that is question number 112. It says that in a coil of resistance of 10 ohm, the induced current developed by changing magnetic flux through it is shown in a figure as a function of time. The current which is developed, the induced current which is developed, is given by the graph with respect to the time. The magnitude of change in flux through the coil in Weber will be how much? So this is a question came from the chapter electromagnetic induction, where you will need to use the concept of this one, d phi by dt is equals to the EMF induced. So this should be in mod actually, otherwise it will be minus of E according to Lenz's law. So d phi will be equals to E dt. Can I write it down? Yes. So d phi can be written as, in place of E, that is the EMF, I can write down I into R dt. So R being constant, okay, that is the resistance. Now you need to find out the magnetic flux. If you need to find out, you will calculate its area, right? So d phi will be equals to, R will come out, integration of I dt. Now once you integrate this one, you will see that the correct answer for this one will come out to be 2 Weber. So number 3 is the correct answer, which is 2. Now let us move to the next question, that is question number 113. A car of mass m starts from rest and accelerates to an instantaneous power delivered to the car has a constant magnitude p naught. The instantaneous velocity of the car is proportional to, question from the chapter motion, where you need to know the value of power, force multiplied with velocity. Once you know this one, you can now calculate the instantaneous power from there. Now if you differentiate this one, you will find that the correct answer for this one is root over of t. You just need to differentiate, remember that. So the right answer for this one is t to the power 1 by 2, that is root over of t. Now let us move to the next question, that is question number 114. A train moving at a speed of 220 meter per second towards a stationary object emits a frequency of 1000 hertz. Some of the sound reaching the object gets reflected back to the train as echo. the frequency of the echo as detected by the driver of the train will be how much? That some of the sound is reflecting back as an echo. Now you need to calculate the what? The frequency. Now the apparent frequency formula from the chapter waves Doppler's effect is the topic. So the right answer will be 5000 hertz. For that you need to use the formula f dash will be equals to f v plus v naught, that is the observer's velocity, v minus vs, that is the source velocity. Everything is supplied to you in the question. If you solve this one, the right answer will be 5000 hertz. So option 4 will be the correct answer. I will just click on option number 4. So now let us move to the next question, that is 115. The input resistance of a silicon transistor is 100 ohm. Base current is charged by 40 milliampere, which result in the change in collector current by 2 milliampere. This transistor is used as common emitter amplifier which with a load resistance of 4 kilo ohm, that is the output resistance. The voltage gain of the amplifier will be how much? Fine. My dear students, this is a question came from the chapter semiconductor physics, topic transistor. Okay, out here it is saying common emitter transistor. Okay, now you need to calculate the voltage gain. What is the formula for voltage gain? The direct formula which is there in the videos is voltage gain, or AV, can be written as output voltage divided by the input voltage. Your output voltage will be the multiplication of output current and output resistance, that is RO multiplied with delta IC divided by V in is RI multiplied with delta IB. So look at the question. The output current is given to you, the input current is also given to you, output resistance is given to you, input resistance is also given to you. If you calculate this one, the correct answer will be 2000. This is the right answer. Now let us move to the next question, that is question number 116. A cell having an EMF E and internal resistance R is connected across a variable external resistance R. As the resistance R is increased, the plot of potential difference V across R is given by how much? So it's saying that you have an EMF. Suppose, let me draw the diagram for this one. First of all, this question came from the chapter current electricity, where you need to know the meaning of EMF. Okay, so an EMF and the internal resistance of this one connected together. This internal resistance is actually inside. I have taken it outside so that we can calculate the resistance, and a external resistance R is connected to it, like this one. So if you plot a graph for the potential part, that is V of this two part, then the potential will come out to be option number 4 if you vary it. So this is the right answer for this question. Fine. Now let us move to the next question, that is question number 117. The dimension of root over of, that is 1 by root over of mu naught into epsilon naught R, that is the dimension of C. If you see, speed of light is given as 1 by root over of mu naught into epsilon naught. Permittivity and permeability. Okay. So C is what? C is nothing but your velocity of light. So no need to put the value of mu naught or the expression of mu naught and E naught, epsilon naught, then find the dimensional formula. It will be very tough. So this whole part must be equal to this velocity of light. So what is the formula for velocity? Displacement by time. So option number 4 is the correct answer for this question. Now let us move to the next question, that is question number 118. The half-life of a radioactive nucleus is 50 days. The time interval T2 minus T1 between the time T2 when 2 by 3 of it has decayed and the time T1 when 1 by 3 of it had decayed is. Now you need to calculate the time again, the total time. So how you are going to do this one? You are going to use the concept of half-life, that is from the chapter nuclei. It says that n by n naught is equal to half to the power n, where n is your number of half-lives. So n will be equals to n naught half to the power n. So you can keep it in this way only. For first case it will be 2 by 3 of n naught. So if I put the first case, 2 by 3 of n naught divided by n will be equals to n naught half to the power n. Now you need to know how do you find out the n. T half is equal to the total time. The total time t is equals to t half multiplied with the number of half lives. So put it equation number 1, and then for equation 2 you just need to put 1 by 3 in place of n. N is the number of atoms present at that moment. So how much it has decayed? So how much will be left? So 1 by 3 of n naught. Like that we used to find the questions for half life. So the final answer for this one will also come out to be 50 days. That is the right answer. Now let us move to the next question, that is question number 119. The instantaneous value of alternating current and voltage in a circuit are given by I equals to this value and EMF equals to this value. So the average power in watt consumed in the circuit will be how much? How do you know this question is from which chapter? From the expression only we can say that the question is from the chapter alternating current of class 12. Okay, and then the topic is average power. So the formula for average power is P average is equal to VRMS IRMS cos of phi. Fine. So this VRMS can be written as 1 by root 2 of V naught multiplied with I naught cos of phi. So everything is known to you now. V naught is given in the question, that is the maximum value of the voltage EMF, that is this one, right? 1 by root 2. For I naught it will be this one, and phi is known to you, it's given, that is pi by 3. So once you put this one, your final answer is going to come out to be 1 by 8. So 1 by 8 is its correct answer. Use this concept, my dear, you will be able to solve the answer. So now let us find and see the question number last, that is 120. This is the last question for the year 2012. During that year there don't used to be a specific exam called NEET, now which you have. Okay, they used to have AIMS and CBSE mains and prelims. Okay, so I am doing for mains, so please see the last question. That's why there are only how many questions? If you noticed, there are 30 questions in this question paper. Now let us see the question. The transition from the state n equals to 3 to n equals to 1 in a hydrogen like atom results in ultraviolet radiation. Infrared will be obtained in the transition from. Okay, now you need to know which series it is falling. N3 to N1, it's in which Lehman series, and then see the option. So it has to jump from higher level, it has to jump to higher level for infrared region. So this is 2 to 1, again this is Lehman series. 3 to 2 Balmer series, 4 to 2 Balmer series. Okay, Balmer is in visible and Lehman is in ultraviolet. The remaining one is this one, option number 1. So this is a question came from the chapter atoms, topic spectral series of hydrogen atom. If you see that, the concept will be very much clear to you. So number 1 is the correct answer for this question, that is 4 to 3, that will give you the infrared region. So this is where we finish all the questions, that is the 30 question. Revise the topics first, then solve the questions, it will be easy for you. Some of the questions I have given you the full answer, some of the question I have just let you to practice and find the answer. The concept is given to you and the formula required is also given to you. That's all. Thank you.